on this computer. All right, so again, we're just going to do some OOP review. I'm going to create a file, OOP.py, open that up, OP into a new VS Code window. Well, that's weird. Why did it do that? Oh, well. All right. So let's talk about classes. So if I were to create a tree class, so class tree, I'm going to dump dunder init. What's the init method? What is that for?
Basically initializes at the start. When you make the object, this is the starting definitions of it. Basically, it's the first thing that starts. It initializes.
Yep. So this method is automatically called when you create a new instance of a tree. And in here, always takes in the self keyword as the very first argument on all instance methods. So self keyword, and depending on what we want about this tree, let's see, what are some things that we want to know about the tree class? So maybe like age of the tree. I could also do like type of tree, but I want to hold out for that. I'll actually just say like is planted.
Deciduous or non-deciduous? Or look, so
What is deciduous? What does that mean? I haven't heard that word. I can't even spell that word.
like
Evergreen or
leaves
non-evergreen.
or leaves or whatever.
Oh, okay, yep. How do I even spell deciduous? That's a good Google, not limnu. I can't.
DE.
There it is, deciduous.
There we go. What is it like? I'm not afraid of people looking at my Google searches, not because of what I'm looking up. It's just how many words I have to figure out how to spell. We can say, yeah, I'll just say like is deciduous. We have no Boolean value initially, or no default value. Is deciduous. And I'll just say is deciduous. And for this one, I'll just say also I actually put like age. Self.age equals 0 initially. So I've got this dunder init is automatically invoked when I create a new instance. Let's go ahead. So if I wanted to create a new tree, like tree 1, I can create a tree instance. Is deciduous, I'll say true initially. And I can print tree 1. And if I wanted to invoke that, Python OOP, there we have our tree object. And if I wanted to access each individual instance variable, I can just call that instance tree_1 is deciduous or age. And if I wanted to see those, run those, it's true with an age of 0. So now we can also, instance methods, instance variable, unique to each instance. I would say the value is unique to each instance of the tree class. So these are instance variables. How do I know it's an instance variable?
Self.
Yep. So yeah, it has the self keyword on the variable. So these instance variables, I have access throughout the entire class. I don't need to pass it into any methods. I just automatically have access to this age by calling self.age throughout anywhere. So if I wanted to create age tree, which is going to be a instance method, where this will increase the age of the tree by 1 each time. So I
I
can
have a
just
quick question about the instance variables.
Yep, go ahead.
Do you have to call them or initialize them all under the dunder init? Or let's say for whatever reason, I have a method down there that's going to create a variable that I want to be able to continue to use. Can I initialize a self like under one of the methods?
Yep. So you can definitely, so it's best practice to initialize all your instance variables within the dunder init, but you don't have to. There's nothing saying you actually have to, like the program won't break. But for example, so I'm just going to create, I just literally created an instance method called create instance variable. And I can create a new instance variable by just doing self.new instance variable equals, this is an instance variable. So when I initialize tree the first time, when I create a new instance of a tree, I only have access to the is deciduous and the age instance variable. I don't have access to this instant variable until I invoke this create instance variable method. So if I wanted to see like, hey, what is new instance variable? If I run that, we'll say, hey, no attribute new instance variable. But if I call tree1 dot create instance variable and I invoke that, and then I try to access the new instance variable, I'll have access to that. So that's the only, you just have to make sure if you want to use that instance variable that isn't initialized in the dunder init, that you have to call whatever method before you access that instance variable of wherever it's created. But best practice, just initialize all your instance variables in the dunder init and you won't have any issues accessing instance variables. Because maybe I wanted to access this instance variable in another method and I forget to call this method. So I try to access the new instance variable before it's actually created. But yeah, but there's nothing saying you can't do that. A good question. So we have this age tree. I can increase the age of the tree. So age tree, age equals plus equals 1. And so if I wanted to age the tree, I can always just, I don't have to return anything here, but I'm just going to return the self.age as well. So if I wanted to, age the tree like 3 years, I can do tree1.age tree. I can invoke that 3 times or call that 3 times to age of 3 to the age of 3. And then I can print the age. And now we have the age is 3 years old or whatever. So this is an instance method. You call these methods on each instance of the tree. What else? Those are the main. Then we have instance, or we have class variables, such as that are the same across every single instance. What is something that would be the same across all instances of a tree? I'm just trying to think. What? I'm sorry.
As bark.
Has bark.
Right.
Do all trees have bark?
Probably not.
Probably not, but let's just assume like, we're just looking at trees in like the continental US. Hopefully they all have bark. So if I wanted to check to see if this tree has bark, I can say tree 1 dot has bark. I can print that. If I run that, we have true. And if I created a new, like tree 2, and made this like a false, I can see if tree 2 has bark as well. That is also true right there. And if I wanted to change, like def change, like change bark, I can make that. I don't know if this is, but I would want tree dot has bark equals false. I just want to show you like I'm able to change this class variable on each instance of the class. So say if I wanted to do tree 1 dot change bark. So I'm changing the bark on tree 1, but on tree 2, it will also should change. So right there, and I can also just make sure that it's also changed on tree 1, like so. So initially has bark is true on both. Initially it's true. On one instance, I changed the entire class variable to false. Now each instance is false. So class variable, same value across all instances of tree. So yeah, this is just changes class variable value and is reflected across all instances. All right. Any questions about instance variables, class variables, and instance methods so far?
So true and false is deciduous, right? Just want to make sure.
Yeah. So yeah, that is just a Boolean value, true or false, and that's what I'm passing in when I'm instantiating a new tree. So I can say, oh no, what did I do? Like tree 2 is deciduous, and that should be false. Is deciduous. So tree 1. Yeah, false is right there. All right. So let's talk about, well, what other questions do y'all have about that?
If we, for change bark, since we're changing the class variable, wouldn't that be a class method?
It doesn't have to be like, yes, you should, like, you probably should make this a class method. So yeah, so this is instance method. But right, if we are changing a class variable, it's probably best practice to make it a class variable. And with that, you'll need to create this add a decorator class method, add CLS instead of self, because you're referencing the class. And now instead of accessing tree, this will still work doing tree.hasBark, but this class CLS also references the class tree. So this will also work. And typically when you do a class method, you don't need to run this change bark on an instance of a tree. You can just run it directly on the class itself. So tree dot change bark and invoke that. What did I just do? And now I can do print tree tree dot has bark. Python OP, and now it's false.
Cool, thank you.
Yep. So that's a good segue to class methods. Methods that you can execute only on the class, not the instance, not an instance. Of and you need this decorator to make that a class method. All right. So you'll see these class methods, but you don't always need, like, you can still make the program work without class methods. You'll just have to do a little, just like your syntax might look a little bit different. All right. So let's talk about inheritance. And all right, so let's keep on using this tree and keep building upon that, the tree class. So what is inheritance? Someone tell me.
It's when a subclass inherits the methods and variables of its parent class, and it has a relationship.
Yep. So if we're to use tree as a parent class and create a subclass of a tree, we can get into a little more specific. So let's get into like a specific type of tree, like an oak tree. And an oak is a type of tree. So it's an is a relationship. So oak is a tree. So it inherits from the tree. And it'll inherit all these attributes. It'll inherit the is deciduous, the age, instance variables, this age tree instance method, this has bark class variable, and this change bark class method. So if we want to do an oak tree, we can dunder init, and we take in self. And if we're inheriting is deciduous as well, I'm gonna actually get rid of those. Yeah. What other attributes can we have for like an oak tree? What are some attributes about an oak tree? Does anybody know?
Got acorns.
Acorns? Cool. So we'll have to pass in is deciduous, has acorn, would it be just acorns or has seeds? Because do all trees have acorns or do they have other types of seeds? So I'll just say like has seeds, or I guess just keep things simple. It has acorns.
I think acorns are nuts.
Has I know there's like I'm sure there's a more scientific term of how it actually spreads. It's
Google says all oaks have acorns.
all right. So I'll just say have acorns. What else should we put? I don't know. Is
Safe
like
to burn.
safe to burn. Like what kind? Because I don't know if anybody's actually like done like woodworking or anything. Like obviously different woods have different, not just texture, but like how hard the wood is. So like I know oaks are extremely hard. They're not the hardest out there, but they're definitely more hard than like pine and like a lot more difficult to work with as like a carpenter. So I can say like wood type, I don't know. Wood type, hard, medium, soft. So anybody else have any? See, like oak tree.
Well, your acorns could actually be associated with age.
Okay. So like
Acorns oak trees don't produce acorns until 20 years.
okay, yeah. So like that's really good to know. So like we can say like has acorns. Awesome. So initially we can say it's like false.
Until age
Until-
is
Yep.
equals or
20.
greater than 20.
Yep. Oak tree attributes. Characteristics in red oaks. So we can even get in like the more specifics about oaks because there's like red oak, white oak, black, all that stuff.
Maybe like has sap, doesn't have sap. Like
Yes.
super sap, you know.
Yeah, we can keep going with this. But yeah, so like let's just keep it like this so far. And I'll actually put has acorns. And we'll just use acorns as like a default for like any type of seed. So if the oak tree, or actually, yeah, if the oak tree is inheriting from the tree class, how do we pass in the is deciduous from the oak class to the parent class? Does anybody remember the syntax?
Super?
Super.
Yep. So super refers to the immediate parent class of the current class. So super refers to tree class. We can do dunder init, and we'll just pass in is deciduous, and we'll do self dot wood type equals, oh, that's just a hard, and self dot has acorns, and that's initially going to be false. All right. So if we wanted to age the tree, so actually let's go ahead. And if we want to do, we can create a class like pine and do the same thing, inherit from the tree class and do everything the same, like is deciduous wood, has acorns. We can even add like additional attributes that are specific to pine tree if we wanted to, but we don't need to do that. So again, inheritance is a relationship. Is a relationship. So if I wanted to create a couple or an instance of an oak, so oak 1 equals oak is deciduous, is an oak tree is deciduous. Does anybody know?
Yes.
True.
It's deciduous, yes.
So wood type. So I guess that could be default like hard, but I'll just actually pass it in, and has acorns. It's going to be false. I don't necessarily have to pass in false here because it has a default value of false. Likewise with wood type. Okay, so I created an oak tree. I can print an initial oak. And if I wanted to run that, we've got our oak tree object. If I wanted to see the age or like is deciduous, I wanted to see the age, these attributes, wood type, and like has acorns. So if I want to see all that, true, it is deciduous, age 0, it's a hard.
You could have something that is 2 minutes down the road come drop us off.
What?
You could have,
Is
Never
that,
mind.
is that Sam?
oh, my bad. That was to my roommate, my bad.
Very good. I was like excited about it. Well, I can have what about an oak tree? All right. So we have the age is deciduous wood type. So is deciduous and age are inherited. These attributes, these instance variables are inherited from the tree parent class. And wood type and has acorns are from the subclass or the current class, the oak class. And if I wanted to age the tree, age, I can invoke it and I can check the age there, clear, and run that. Uh-oh, what did it say? Age. Oak tree age. Oh,
I think you named it age tree.
is that what I did? Thank you. Yeah, because it can't have the same method name as the same variable. There we go. So age the tree. But I want to somehow make sure I don't know who said it, but like, all right.
Over
Oak
20 years.
Okay, thanks, Stephanie. Oak trees don't produce acorns until they're at least 20 years old. So I want to override this age tree method because this is initially inherited from the tree parent class. So I can actually go ahead and just age tree. I'm overriding it. I can do self. And for this method, I'm just gonna like, age tree. This probably isn't the best. So I'm going to give it an optional variable to age the tree up until it's able to produce acorns. So I can age the tree by 1 year, or I can age the tree up to it's able to produce acorns. So if I add false, it's going to age it up until it's at least 20 years old. And then it's going to change this has acorns to true. So I can say if to produce acorns is true, while self.age is less than 20, self.age, I guess like I can literally just say self.age equals 20, else self.age plus equals 1, and then just return self.age. So this is just an optional attribute. I can just immediately make it age 20. And once it's able to age 20, I can say self.has acorns equals true. So if I run this again, I'm gonna comment out has acorns and age. So I has acorns is false. I aged it 1 year. I'm not passing any in that attribute in or that argument in to produce acorns because it's initially false. So when I do age the tree, it's only ages at 1. But if I do want to age it up to the point where it produces acorns, I can age tree to true, and it produces it, or it runs it all the way up to 20. And now it's also able to produce acorns, or it has acorns. All right. Any questions about inheritance and how to inherit from a parent class and have that subclass pass all the attributes from the subclass to the parent class and overriding instance methods?
Can I see your tree class real quick?
Yep.
Okay, thanks.
All right. So we've talked about inheritance. So inheritance is a relationship, but now let's also talk about composition. So if inheritance is a relationship, can someone tell me what composition is?
Has it?
Yep. So composition has a relationship. So continuing on with this oak tree, if we wanted to add a class to this oak, let's actually go down here. We can get rid of this pine because we don't really need that. So what can we add that would be like has a relationship? A oak tree has a what? What are some objects that we can create that an oak tree has?
Leaves.
Leaves,
Branches,
branches. Kind of talked about some up here as well.
Roots.
Roots,
trunk.
trunk, acorns, stuff like that. So well, let's go with the first one, leaf. So class leaf, like so. And def, dunder, init, self. What can we talk about? Like what kind of leaves are there? I don't know.
Narrow, broad.
All right, yeah, just like I don't know, type. And that would be like
What type
narrow,
of green they are, or their color, I guess.
very green. They're that color. What else can we do? Like size.
Yeah, size.
All right, so self dot type narrow, narrow and wide. We'll just say like the type is narrow and wide. And then color, we can just like light green, dark green, brown, whatever. Self dot size, and we'll actually have like a numerical value for size. 1, 2, 3. It could be inches, centimeters, whatever we want. All right. So if inheritance, we pass tree directly into the oak class, so it inherits all the attributes. How do we create, like, who's our tree expert? Stephanie, anybody can answer this. At what point do oak trees start producing leaves? Somebody know?
When they're saplings, I would think.
How long do they become saplings?
Let's find out.
Yeah. So self dot leaves. And in here, I can even like, once I initialize create an oak tree, I can automatically create a leaf class and pass in, narrow. What were the other attributes? I'm going to bring oak tree, all this stuff down here. Type, color, green, and just say like 1. But typically, like when does an instance of an oak tree get created? Is it right when you plant the seed? Is it right when, you know, a squirrel goes, picks up the acorn and buries it, and then like, hey, you just created an instance? It's when it sprouts, gets some water, and it, you know, grows. So maybe it doesn't have any leaves right when it initializes, when it creates a instance of an oak.
You're not gonna like this, but you'd have to create another variable to track the height.
For the oak tree?
Yeah, their seedlings become saplings, and that's that's quantified by 3 feet tall. And once it
Seedling,
becomes a sapling, then it can produce leaves.
And what height is that? 3 feet?
3 feet tall.
Okay, so we'll do height of 3. I'm not going to pass in any. I'm not going to initialize. It's just going to always, when we create a new instance of an oak, it's got a height of 0, and it doesn't have any leaves at that point. So when we age a tree, we can also. I didn't mean to do this, but Rick, I'm kind of helping you do one of the challenges. So when we age the tree, we can also grow the tree. So every year it grows by self dot height plus equals 3. So it grows 3 feet every year, and self dot height equals self dot age times 3, right? So 20 will be 60 feet tall in 20 years. All right. So every time we age the tree, it also grows. All right, well, crap. Maybe. So like, all right, I'm doing a lot of stuff in here. So as it grows, it also needs to produce leaves. So I'm going to add, whoop, I just did something. Def dot make or create leaves, and takes in self. And every year after the height of 3, let's see, it's going to create like a random number of leaves every year. So how do we want to do that?
We'll need to import random first.
Yep, I'll have to import random. Or yeah. All right. So I'm just trying to think off the top of my head. So once create leaves, and I'm wondering where should I do it? Like, should I add so every year, if height is greater than 3, run this method. All right, that's what I'll do. If self dot height is greater than or equal to 3, every time I age the tree 1 year, it's going to self dot create leaves, and that is going to random number of leaves equals random dot rand int, and it creates a number of, is that inclusive or exclusive, between 1 and 10? Is that how that works? Or I in range random number of leaves. What is it going to do? It's going to self dot leaves dot append, and it's going to create a new instance of a leaf. And where's the leaf type? I'll just say like narrow. They're all going to be the same leaves. Green. I guess for the size, I can also do random dot rand int between 1 and 3. And it returns. I guess it doesn't necessarily have to return anything. So every time it age a tree, let's just say we're not going to run that, produce whatever. It's going to age the tree 1 year. It's going to every year it increases the height of the tree by 3 feet. Let's just say 3 is the 3. After the tree is 3 feet tall, it starts to create leaves, and it produces a random number of leaves between 1 and 10 every single year. And so like comes over here, self.create leaves, picks a random number of leaves to create between 1 and 10. If I'm using this correctly, we'll find out shortly. And for I in range, random number of leaves, that's inclusive or that's exclusive. It appends a new leaf to all the leaves, which is an array. So it's going to be an array of leaf instances. So I'm just going to create another method, leaf count. That just returns the length of self.leaves. Now also just print self.leaves in here, just so you can see it's an array of objects. Right. So what questions do you have about aging the tree, updating the height every time the tree ages a year, and then also creating leaves if the height is greater than or equal to 3? All right. So if I were to run this, oh no, not return. So has acorns? No. So let's just get rid of all that. Let's age the tree just 1 year and print I'm just going to print the oak 1 dot leaves just to see the leaves initially. Or I guess leaf count. So I'm going to invoke that. And then if I age the tree 1 year, it should increase and create a number of leaves. So look at that. So initially the leaf count is empty, or the print leaves, it's an empty array. The initial age tree, so I age the tree. Let's see what that does. Age tree. Why does it show 0 first?
Because you have the return length under the leaf count. Yeah, right there.
Oh,
you
yeah,
have
I'm an idiot. Okay,
length.
thank you. And then, so I age the tree. Now the age is 1. So produce age is 1. And then, so if I got rid of that print statement and did the same thing. So the age is 1. And then I did the leaf count. After it's 1 year, it's 3 feet tall. I can also run that by saying height. So if I did that again, so age is 1, it's a 3 feet tall, and here is an array of leaf objects. So there's 6 of those. So each leaf has its own attributes such as type, color, and size, and there's 6 of them in here. And so composition has a relationship. So it doesn't inherit it like so, but we can instantiate a new instance because an oak has a leaf. And so that's what I'm doing here, creates a random number of leaves. So this is the has a relationship. Oak has a leaf or leaves. And I can do def dunder string. What does the dunder string method do?
Makes it look nice when it prints it to the console.
Yep. So maybe I wanted to see the type. Make that an F string. Self type. Color. And size. Let's see what that looks like. Still the same, but if I wanted to view all the leaves, def, like leaf view, leaf attributes. I can loop through. So for leaf and self dot leaves, print leaf. View leaf attributes. So this leaf only has one, so it's narrow green and the size is 3. If I want to do that again to see if there's more. Oh, for leaf and self dot leaves. There we go. We got more there. So we got 3 leaves, narrow, and these are the size of each leaf. All right. So that's composition. So it has a relationship. So we could also do, we can create more classes like branches, acorn, all that those will have. So we'll have like an array of branches and an array of acorns, whatever this specific oak tree class needs. Any questions about composition, inheritance, or anything?
So to use a has method, you could call that anywhere in the class, like within any method. All you have to do is just doesn't have to be initialized anywhere like the super does or anything. Yeah, right there.
Nope. You just like create a new instance, just like you do kind of down here. So yeah, you don't have to do super. It's just like creating a new instance of a leaf. You don't have to do super. It's not passed in. The syntax isn't as.
But if let's say that if that class was somewhere else in another file, then you would just have to import it.
Yep. So exactly. If like leaf was somewhere, I'd have to say like from some leaf file, import the leaf class, like so. All right.